My dear students of class 10, we know about light, refraction of light, right? At first we discuss refraction through a prism, glass prism, and then after this we discuss the different terms about spherical lenses and refraction through it. Right? Prism, refraction through prism. Refraction through prism. A prism is a reflecting medium. Right? In which it will be written in broader form. In this case, it has two rectangular faces, and this is the two planes meet at this line. We name it P, Q, R, S, T, V. Right? These two faces are rectangular faces. Are meet at a point. This is called the edge of the prism. Here we see, and two are rectangular faces and another below the two rectangular faces is also rectangular. Two triangular faces in its side. If we cut it, we cut the edge perpendicularly, then we have this A, B, C. Right? These two faces makes an angle. These two planes, the rectangular planes, they meet at the called the edge, makes an angle. This is called the angle of refraction, angle of reflecting angle of the prism. Remember it. And it is the principal axis. ABC be the principal axis. We all refractions deal with only principal section is taken, not the whole prism is shown in the figure when ray diagrams are required. Right? Let this is a principal section of a prism. Principal section of a prism. A, B, and C be the principal section of a prism. It is the principal section of a prism. Principal section of a prism. This is the angle of the prism A, right? A be the angle of the prism. This is the angle of the prism. Angle of the prism. Right? Now we draw in different color. The ray diagram will be such that this is the angle of incidence. It is the PQ. Will be written as PQ. at Q, reflection occurs. This is the normal at Q on the face AB, on the reflecting surface AB. This is the normal, that is angle will be the 90 degree. This is the 90 degree, right? And since the light rays from air to prism reflected from air to prism, hence its angle of incidence, that is I1, this is I1 is greater than the angle of reflection, that is it reflected ray bends towards the normal R. Again, at the point R, it is reflected. We draw a perpendicular at the point R also. At the point R, on the reflecting face AC. Let these 2 points are meet at N, right? Then this is the normal. This is the air glass prism. This is a glass prism. And air. This is air. Here the reflected ray bends away from the normal. Hence, it bends. This is called BC is called the base of the prism towards the base. Right? Here, two deviations occur due to reflection at Q and R. If it is extended, that is, this ray be extended, PQ be extended, the incident ray be extended, then here, this is the PQ be the incident ray and QR be the reflected ray, right? Here angle, this angle is R1, this angle is R1, angle of reflection R1 at the due to reflection at Q. Here R2 angle of reflection, and this is the angle of emergence, that is we write it I2, or if we may write it I1, we write it as I, R1 we write it as R, R2 we write it as R dash, as R prime, and I2 may be written as E, angle of emergence, right? Now, in this case, the original direction of the incident ray and the direction of reflected ray makes an angle delta 1, which is the deviation produced due to reflection at Q. Deviation of light ray produced due to reflection at Q. Here also reflection occurs, that is QR to emergent angle S, PQR S, this written as S, right? Now, if we measure deviation, then in this case the deviation will be this. Right? In this case, this is the incident ray and this is the direction of incident ray. Right? And this will be the delta 2. Right? Delta 2. Or this will be the, obviously, this will be the, this is the direction of incident, and if we extend it backwards, it produced backwards. Then this will be the angle of deviation due to reflection at R, right? And this is the angle between the original direction of the incident ray and the emergent ray. Hence, it is the total deviation produced due to reflection of light through a prism. This is incident ray, incident ray, refracted ray, and this is emergent ray. Right? Now we calculate delta. Right? Here we see that R T. I could write it T. The T U or T free. Right? T obviously present, not T free. T U. Right? Here delta is the angle obtained due to produced of a side of the triangle QTR. Hence it is the exterior angle due to extended of one side of the triangle. Hence it is equal to the sum of the opposite interior angles. That is delta equal to delta 1 plus delta 2. Right? In your exercise book, you note this point. That is, the deviation due to reflection through a glass prism is the angle between the original incident ray and the emergent ray. This is the total deviation produced due to reflection through a glass prism. This is denoted by delta here. Here, due to the refraction at Q, deviation produced be delta 1, and here due to refraction at R, delta 2 will be the angle of deviation. And delta equal delta 1 as delta 2 due to triangle QRT. Here QT produced backwards, or Q2 extended forwards, then and RT or SR produced backwards, then the angle between these will be the delta or total deviation produced. And delta equal to delta 1 plus delta. What will be the delta 1? Here delta 1 will be the obviously I1 minus R1, and delta 2 will be the here I2 greater I2 minus R2, because this is the incident ray and this is the I, and this is the direction of normal, and this is R1. It's this angle will be the total angle will be the I1. Hence, if I1 is subtracted, R1 is subtracted from I1, we get the deviation due to refraction at Q. Similarly, we get the deviation due to refraction at R will be I, delta 2 equal to I2 minus R1. We write it I1 minus R1 plus I2 minus R2. Right? Then I1 plus I2 minus R1 plus R2 will be the total deviation produced. Now we prove that R1 plus R2 equal to angle of the prism. That is I1 plus I2 minus A is the relation delta. We see it how we get. We prove that R1 plus R2 equal to A. Right? We prove that R1 plus R2 equal to angle of the prism A. Angle of the prism. Angle of the prism. Right? We prove that R1 plus R2 equal to A, the angle of the prism or angle of the prism. Right? Prove it. We see that this is 90 degree, this is also 90 degree, angle N, angle A, right? It is, that is QNRA, QNRA is a quadrilateral from quadrilateral AQNR, we get the sum of the four angles will be 360 degree. That is, angle A plus 90 degree plus angle N plus 90 degree equal to 360 degree. Write it clearly. We write it clearly. We get angle A, we dash it at first. Angle A plus 90 degree plus angle N plus 90 degree obviously will be the 360 degree, because the sum of the four angles of a quadrilateral will be 360 degree. That means angle A plus angle N equal to 180 degree, right? Again, if we take this triangle, that is QRN, from triangle QNR, we get R1 plus R2 plus 90 degree. This is R1 plus R2 plus N, angle N, equal to 180 degree. That is the sum of the three angles of any triangle will be 180 degree. Angle sum property of a triangle. We get R1, angle R1 plus R2, angle R2 sin maybe angle N equal to 180 degree, right? If we compare these two, this and this, if we compare N common, angle A equal to R1 plus R2 obviously, because both are angle A plus angle N equal to 180 degree and angle R1 plus angle R2 plus angle N equal to 180 degree. Hence, this is common and these are equal. Therefore, A equal to R1 plus R2. That is angle A equal to angle R1 plus R2. Hence, we get delta equal to I1 plus I2 minus A. Remember it. Now, if we plot a graph between angle of incidence, various angle of incidence to the angle of deviation, we get the following graph. Here we also, it may be written as delta plus A equal to I1 plus I2. It also written in this way, right? Now, we take the graph. O, X, Y. Angle of incidence in the abscissa, that is x-axis. Angle of incidence in this side, that is I for different I, and angle of deviation through y-axis or ordinate. Angle of deviation with this axis, y-axis or ordinate, right? Here we are starting from 20, 40, all are in degree, 60, 80, 100, etc. And also in this 20, 40, this is also in degree, in degrees, 60, 80 or any other values. Here the nature of the graph, we see it in light color will be 80, 100 or any other values may be taken. Here the nature of the graph will be this. Nature of the graph will be like this. Right? We see that this is the minimum deviation. This is the minimum deviation, delta M, and it occurs when angle of incidence equal to angle of emergence, that is I equal to E. When angle of incidence maybe I1 equal to angle of emergence, that is I2, right? Or it may be I and it may be E. If it is I, we write it, then it is E or I equal to E, right? Minimum deviation occurs delta M in this way. At first, for small angle of incidence, the angle of deviation will be high. If angle of incidence increases gradually, then the angle of deviation decreases gradually. And then for a certain angle of incidence, the angle of deviation will be minimum. It is called minimum deviation. This is shown in the figure here. Here, angle of incidence is equal to the angle of emergence. And then further, if the angle of incidence increase gradually, the angle of deviation will also be increased gradually. Right? Some points are shown here. This graph is very important for your class. For this chapter, you show in your exercise book clearly, right? And this proof is also important. Now, we know something about some terms or a lens in the next class, right? And then, okay. Thank you.